All right, guys, day 53 of the 100 Days of LeetCode. We got an easy problem here. It's number 232, implement queue using stacks. Let's get right to it. So we want to implement a FIFO queue, first in, first out, using only two stacks. The implemented queue should support all the functions of a normal queue. We got push, peek, pop, and empty. Now, implement the myQueue class. We want to push the element X to the back of the queue. We want to pop it. So basically push, you're pushing something on top of the queue. Now, if you don't know, the way of a queue works is, you're pushing to the back of the queue. The way a queue works is it stores a bunch of elements, and the first one that was inserted is going to be the first one that comes out. So you can think of it literally as a line at the grocery store, a queue at the grocery store. You know, the first person in that line is going to cash out first. The last person in that line is going to cash out last, and then people come to the back of the line and so on and so forth. It just keeps moving, okay? So pushing puts something in the back of the queue, pop goes from the front of the queue, and we return it as well. Peek only returns the element at the front of the queue. It doesn't actually get it out of the queue, it just returns it. And then empty just checks whether or not the queue is empty. Now, we can only use the standard operations of a stack. So basically push to the top, peek, pop from the top, size, and is empty, okay? Only those are valid. Now, depending on your language, the stack may not be supported natively, so you have to simulate a stack, and we're going to be using Python, so that's what we're going to be doing. Here's an example of basically the problem. Basically what it's doing is it's putting it through sort of a series of problems like this, and it's checking its correctness. So let's get started. So we have two stacks that we can use, and again, it's Python, so we're just going to simulate them with a list. So I'm going to say self.main equals an empty list, an empty stack, let's imagine. Self.helper equals an empty list, empty stack. Now, if we want to push, that's pretty easy. We can just use self.main.append X. Now, I know it says here you can only use a standard operation on the stack, which means only push top, peek, pop from top. They're going to be called different things, but essentially the main idea is to just keep to the spirit of what a stack does. So we're essentially just pushing to the back of the queue. I keep saying stack, but we want to simulate these being queues, right? We're using stacks, but put together, they're going to simulate a queue. So we want to push to the back of the main stack, okay? And the way we're going to simulate a queue is whenever we need to do something that is a queue operation, we're going to basically pop from the top of that stack onto the next stack. So we're going to reverse the order, okay? And by reversing the order, we're going to have access to the first element of that main stack at the top of that second stack, okay? So it's going to work a little bit like this. If we want to pop, what we want to do is you want to say, well, self.main not equal an empty list. And again, this is pretty much just the is empty operation. It's essentially what I'm doing. We're going to do self.helper.append self.main.pop. Okay, so basically we're just taking from the top, putting it on the other stack until the helper stack has basically the reverse contents of the main stack, and the main stack is empty. And we can say result equals self dot helper dot or I guess we could just do -1, right? Because we just want the top of the of that particular stack. Okay. Now what we want to do is just so we keep our two stacks in order. Again, I'm referring to them as stacks, but in Python they're lists. But I'll keep calling them stacks just to keep with the spirit of the problem. To keep them in order, we want to take from the helper stack, put all the values back onto the main stack. So they're going to be in the exact same order that they were in initially. Of course, now we're going to have one less value because we have popped it. And actually, yeah, we want to pop this, right? Because we want to actually take it off the helper stack. So now what we're going to do is we're going to say, well, self.helper not equals an empty list, empty stack. Self.main.append self.helper.pop and return result. Okay, so that's how we do the pop. To do the peek, we can literally just copy and paste this code. But we do need to make one change. Here, we're not going to pop the item, right? We're just going to get the last index and return that at the end. Now, you can write, I guess, another method for this whole little reversal and then reversal that we got going. But, you know, I'm just not doing that. So here we just want to return, this is the empty method. Now what we want to do is we just want to check whether or not we have an empty queue. So we're going to check our main stack, see whether it's equal to an empty list. So that should be our solution. Okay, so there you go. So that's how you can implement a queue using two stacks. Tomorrow we're going to be doing the opposite, implement a stack using two queues. So I hope you guys enjoyed that video. If you guys enjoyed it, please like, subscribe. Back tomorrow with day 54.